Aluminium and aluminium alloys can be joined by a wide variety of brazing and soldering processes. Brazing, by definition, employs filler metals, having a liquidus above 450 C and below the solidus of the base metal. Soldering is distinguished from brazing by melting point of the filler metal. Solders melt below 450 C. Therefore, aluminium alloy fillers are not used in soldering aluminium. Most solders for aluminium are alloys of zinc and tin. Soldering aluminium differs from soldering other como metals. Aluminium's oxide films requires active fluxes, designed specially from aluminium. With aluminium, resistance to corrosion depends much more on solder composition than it does with other metals. All soldered aluminium joints have a lower resistance to corrosion than those that are brazed or welded. Although all aluminium alloys can be soldered, alloy composition greatly affects ease of soldering, type of solder, method employed, and ultimate service acceptability of the assembly. In the figure is listed the relative solderability of the principal wrought aluminium alloys. Solder for aluminium can be classified as low temperature, intermediate temperature, and high temperature. General characteristics of typical solders of each type are listed in the table. This table excludes several popular cadmium and lead-containing solders that have been banned in recent decades. Low-temperature solders melt at 150 to 260 C. They are composed primarily of low-melting metals, such as tin and zinc. Intermediate-temperature solders melt at 260 to 370 C. They contain primarily tin in various combinations with zinc. High-temperature solders melt between 370 to 450 C. They consist of 90 to 100% Zn and may contain 2 to 10% Al. Fluxes for soldering aluminium are two types: organic fluxes and chloride-containing, inorganic salt, reaction fluxes. When heated, organic fluxes react with the oxide film and remove it from the aluminium. Reaction fluxes penetrate the oxide film and contact the underlying aluminium. Joints to be soldered with use flux must be designed to permit application of the flux. Provision must be made for the flux to be displaced by the filler metal, because entrapped flux is a potential source of corrosion. Joint design must also allow the escape of gas and subsequent penetration by filler metal to ensure the complete distribution of filler metal in the joint. For flux soldering, self-fixturing is an excellent assembly method. It may be accomplished through the use of tabs, rivets, screws, press fitting, springs, clips. Spring-loaded fixtures can be useful, especially for high production and complicated assemblies. Weighed fixtures are often used on low production runs and in cases where variations in shape and size preclude the use of more expensive future types. And as always, thanks for watching. Remember to like, comment, and subscribe.